Let's now talk about exactly how a Bloom filter works. Remember from the last video that a Bloom filter is a probabilistic data structure that supports adding an item and checking to see if the filter contains an item. It does not support removing an item, and the contains operation, because the data structure is probabilistic, is not always correct. Contains will sometimes say that the Bloom filter does contain an item even when it doesn't. You get false positives. But if a Bloom filter says it does not contain an item, then you know it's correct. So the way the Bloom filter works is it has a bit array. A bit is either 0 or 1, so every single box I'm drawing here represents a bit, and so every single box is either 0 or 1. I'm going to call this bit array B. And to begin with, so when the Bloom filter is initialized, every element in the bit array is equal to 0. And then as we add items, some of these bits are going to be set to 1, but they'll never be set to 0. So what happens when you add an item? Here's what happens. So the Bloom filter has a number of hash functions associated with it. And talk about what a hash function is in a second. But for each hash function in the Bloom filter's set of hash functions, we compute an index into this bit array by applying the hash function to the item, and then we set the bit at that index equal to 1. So let's say, as an example, that we have a Bloom filter. So to begin with, all the bits are 0, and we go to add an item. So let's say we go to add maybe a picture. Maybe we're adding pictures to this Bloom filter. So we have a few hash functions, and each hash function, I'll tell you what a hash function is now. A hash function takes an item as input, and it maps it to a number it maps it to an index of this Bloom filter. So that will be, let's say that there are m slots in the bit array. It'll return a number between 1 and m. So hash function takes an item and maps it to some spot in the bit array. Back to the example. We were adding a picture to the Bloom filter. So we take the picture, we apply the first hash function to it, and that says, look at index 3. So we set, it doesn't have to be 3, just an example, we set index 3 to 1. Then we apply the second hash function, and it says, look at index 7. And so we set index 7 to 1. 4, 5, 6, 7 becomes 1. And we do this for all the hash functions. So that's how you add something to the Bloom filter. And now you want to check, does the Bloom filter contain an item? And so that works in much the same way. For every hash function associated with the Bloom filter, we get an index by hashing the item, and then if any of those indices have not been set to 1, so they're still equal to 0, then we know the Bloom filter does not contain the item. But if all of them have been equal to 1, then the Bloom filter thinks it does contain the item, and it returns true. So this is how the Bloom filter checks contains. And you might notice that there's a problem, which goes back to what I said about contains not always being correct. If we add a whole lot of items, then eventually every single bit in the Bloom filter will be set to 1. And then contains will always return true. And so the Bloom filter will be useless. So in the next video, we'll talk about how many hash functions you need, how big your bit array should be, and what's the probability that contains is right. So when you have every bit in the bit array set to 1, contains will always return true. But there's also the intermediate stage when a large number of the bits are set to 1, where contains sometimes returns true correctly, sometimes returns false correctly, but still has the occasional chance of returning true incorrectly.